In this video, I'm going to demonstrate quotitive division. I'm going to divide 412 in base 6 by 3 in base 6, and I'm going to demonstrate division using drawings. When I'm using drawings to demonstrate any operation, I should keep in mind the view of the operation I'm trying to show. If I'm thinking about quotitive division or repeated subtraction, then the division problem 412 in base 6 divided by 3 in base 6 is you have this many things and you'd like to make groups of this size. We have 412 in base 6 things and we'd like to make groups of size 3. The question is, how many groups can we make and how much is left over? That tells me how I should start my drawings. I should begin with this many things, 4 36s, 1 6, and 2 1s, and I need to make groups of 3. Since I want this to demonstrate the standard algorithm, long division, for long division, we work our way from the largest place value to the smallest. So when I'm making groups of 3, I'll begin by making groups of 3 in the 36's place, then in the 6's place, then in the 1's place. As always, every action that I take should be its own separate drawing. So to begin, we have in the 36's place 4 36's, and groups of 3, well, I can make one group of 3. So my first drawing has me grouping things in the 36's place, and I'm able to make one group of 3. Of course, that means that I've got a leftover 36, and I can regroup that. I can place that 36 that's left over into the 6's place. Every 36 is worth 6 6's, so I'll have, in addition to the 1 6 that I already had, 6 more. And of course, I'll still have those 2 1s. Now I'll ask myself the same question as before. When I was looking at the 36's, it was how many groups of 3 can I make? Now that I'm looking at the 6's, how many groups of 3 can I make? And I can see that I have one group of 3 and I have a second group of 3. So it looks like I was able to make 2 groups of 3. And we had 1 6 that was left over. And just as before, that can be brought to the next place value. That 6 that's left over could be brought to the 1's place. And so in the 1's place, instead of having just 2 1s, we'll have 6 more. We'll have the original 2 plus 6 more, 1, 2, 3, 4, 5, 6. We'll have 8 1s in total, and I'll make groups of 3 as before. And I've made as many groups as I can, which means that I have finished dividing. I have made my way from the 36's place to the 6's to the 1's place, and there are 2 1s remaining. If I'm stopping at the 1's place to give my answer as a quotient and a remainder, then I'm finished. My quotient is the answer to the question, if we make groups of size 3, how many groups can we make? We made one group in the 36's place. We made 2 groups in the 6's place. We made 2 groups in the 1's place. So our quotient is 1, 2, 2 in base 6. Our remainder, there's 2 1s that are left over, or there's 2 in the 1's place, or 2 in base 6 as our remainder. If we wanted to give our answer as a mixed number, then remember that the answer to the division problem 412 in base 6 divided by 3 in base 6 would be the mixed number of 122, the quotient, with as the fractional part your remainder over your divisor, or 122 and 2/3 in base 6. Here the base 6 applies to the entire number, not just to the 3 or the 2 or the 122. Everything here is being thought of as a base 6 number. Remember our interpretation for this. You could say that we have 1, 2, 2 whole groups of 3 with 2 1s left over, Or you have 1, 2, 2 whole groups of 3, and the 2 that are left over are 2/3 of a group of 3. You have 1, 2, 2, and 2/3 groups. The reason why we're expressing our answer as how many groups is because that's the view of division that I'm demonstrating. I'm demonstrating repeated subtraction, where I want to know if I make groups of this size, how many groups will I have? And those are my answers. I will have 1, 2, 2, and 2/3 groups, or 1, 2, 2 groups with 2 things left over.